Welcome back to CIA Declassified. Imagine a horizon so wide it begins to curve, where the atmosphere thins into a deep, bruising indigo and the sun burns with a cold, unforgiving brilliance. In this silent realm, a pilot sits encased in a pressurized suit, his heartbeat the only rhythm in a cockpit screaming across the stratosphere. The calendar on the ground marks the passage of 1962, but up here, time is measured in Mach numbers and the steady unspooling of high-resolution film. You are a ghost in the machine of JMSUN. The Cold War was a war of line of sight. To the United States, the vast interior of the Soviet Union was a black hole of intelligence. We knew they had missiles, but we didn't know where. We knew they had factories, but we didn't know what they were building. The CIA realized that to win the ground war, they had to conquer the vertical frontier. JMSUN was the answer, a project designed to turn the sun itself into a flashbulb for the world's most powerful camera. How do you carry that camera? The agency needed a platform that was unreachable. They turned to Lockheed and the legendary Skunk Works in Burbank. Under the direction of Kelly Johnson, they built the A-12, codenamed Archangel. This wasn't just a plane, it was a flying thermos. Because it flew at Mach 3.2, the heat was so intense that standard aviation fuel would explode. They had to develop JP7, a fuel so stable you could put a lighted match out in it. The fuel also acted as a heat sink, circulating through the wings to keep the pilot and the delicate film from melting. The Archangel was the sword of JMSUN, slicing through the thin air to bring back the grains of truth. Why the designation JMSUN? In the cryptic taxonomy of Langley, every character carries weight. The JM prefix was the agency's internal area indicator, signifying that the project fell under administrative oversight of the Joint Mission Support Group, specifically tasked with coordinating cross-departmental resources for high-risk aerial reconnaissance. The sun suffix was a direct reference to the solar angle requirement. Unlike later infrared or radar satellites, the cameras developed for this project relied entirely on reflected solar radiation. The missions had to be timed with celestial precision. The aircraft had to arrive over the target at the exact moment the sun provided the optimum shadow length to reveal the height of missile silos and the depth of industrial trenches. It was, quite literally, a mission to harvest the sun's light. We are pulling back the curtain on a hoard of technical secrets, laying bare the mechanical bones and chemical ghost of the world's most ambitious high-altitude heist. JMSUN was a CIA-directed project focused on high-resolution photographic intelligence. The project utilized HiCon, high-altitude cameras capable of resolving a 2-foot object from 13 miles up. Missions were coordinated through Area 51, then known as Groom Lake. The project developed the first radar absorbent material, or RAM, to reduce the radar cross-section of the aircraft. Records show that JMSUN imagery was used to identify the Tall King radar installations across the Iron Curtain. Documentation confirms the use of specialized emulsions on the film that could withstand cosmic radiation at the edge of space. The agency maintained a weather central to predict cloud cover over targets, as a single cloud could blind the JMSUN lens. Operatives used optical bar cameras that rotated during flight to capture panoramic swaths of territory. Records confirm that JMSUN was the precursor to the Corona satellite program. The CIA collaborated with the Perkin-Elmer Corporation to grind lenses of unprecedented clarity. The A-12 utilized a sawtooth edge design to further dissipate radar returns. Pilots wore the David Clark full pressure suits, the same tech later used for the Apollo moon missions. The J-58 engines were designed to function as turbo ramjets at high speeds. Camera windows were made of pure quartz fused to the titanium frame by ultrasonic welding. The project developed static discharge wires to prevent sparks from igniting the JP7 fuel in low-pressure environments. Records indicate that JMSUN flight paths were often disguised as weather research missions to the public. The agency used deception transmitters to spoof Soviet radar during the ingress phase. Memos confirm that the Oxcart program provided the primary operational testing for JMSUN. The aircraft was painted in a radar-absorbent black that also helped dissipate extreme thermal heat. High-resolution film canisters were designed with self-destruct thermite to prevent capture in a crash. The project researched horizon-to-horizon tracking to map entire rail networks in a single pass. CIA analysis of JMSUN film disproved the missile gap theory of the early 1960s. Technical files show the cameras used a vacuum platen, P-L-A-T-E-N, to keep the film perfectly flat during exposure. The SR-71 was the Air Force's later derivative of the original JMSUN platforms. Missions were limited by the pilot fatigue factor due to the extreme physical toll of Mach 3 flight. The agency built a clean room processing facility specifically for the JMSUN oversized negatives. Records verify that the project used star trackers for autonomous navigation when radio silence was required. The A-12 airframes leaked fuel on the runway because the seals only tightened once heated by friction in flight. Documentation confirms that JMSUN provided the first clear images of the Tyuratam missile test range, Tyuratam. The project pioneered vibration isolation systems to protect the optics from engine harmonics. Records verify the A-12 utilized refractory plugs in the fuel lines to prevent vapor lock at 90,000 feet. The agency commissioned a custom film drying tunnel that used ionized nitrogen to prevent static streaks. Documentation shows that JMSUN cameras could detect the difference between a real tank and a rubber decoy by analyzing light polarization. Wow. The project developed triple redundant oxygen systems for the long duration overflights. CIA files reveal that the titanium used for the A-12 was procured through Soviet front companies, as they were the primary source of the ore. Technical reports confirm the use of nitrogen-purged camera bays to prevent lens fogging during rapid descents. The JMSUN confirmed the presence of the first triple-stage intercontinental ballistic missiles. Operatives used micro mirrors in the viewfinder to allow the pilot to verify camera operation without leaving the seat. The project tested thermal baffles to hide the engine's infrared signature from primitive heat-seeking missiles. Records indicate the film was a mylar-based stock that wouldn't become brittle in the extreme cold of the void. The agency developed a coded blink system for communication if the primary radio failed. Documentation shows that JMSUN flights were tracked by a dedicated deep space network of ground-based listening posts. The A-12 used ejectable data pods to jettison intelligence if the airframe was compromised. Technical files confirm the development of silicone-based O-rings that could survive the 600-degree temperatures of the wing edges. The project used analog computers to calculate the precise moment of sun sink for each photo. CIA records verify that the JMSUN provided high-altitude maps used for the Bay of Pigs planning. The cameras utilized automatic exposure control that responded to the changing of the Earth's surface. Documentation shows the project experimented with telescopic lenses that could see the faces of people in a crowd from 80,000 feet. The A-12 was designed to be aerodynamically unstable, requiring a primitive stability augmentation system to stay level. Records verify that the project successfully mapped the entire Trans-Siberian Railway in under 3 months. The agency researched shadow-length algorithms to calculate the internal volume of Soviet bunkers from external photos. Technical reports show that the JMSUN camera lenses were hand-polished to a tolerance of 1/1,000,000th of an inch. Documentation confirms the use of cold plate technology to keep the aircraft's electronics from frying in the thin air. The project developed pressure-compensated fuel tanks to prevent structural collapse during high-speed dives. Internal memos verify that JMSUN pilots were provided with suicide pills disguised as silver dollars. The A-12 landing gear used soybean oil-based hydraulic fluid to prevent freezing at high altitude. Records confirm that JMSUN cameras used aerodynamic fairings to prevent supersonic shockwaves from distorting the quartz glass. The project utilized silver-plated internal wiring to maintain electrical conductivity at extreme temperatures. Documentation shows the agency built a hyperbaric film lab to develop imagery under simulated high-altitude pressures. The A-12 utilized boron nitride coatings on the engine nozzles to survive the 3,000-degree exhaust heat. Memos revealed the use of coated pulsed lights on the wings for emergency visual signal during radio silence over the USSR. Technical files verify that JMSUN cameras were calibrated using artificial sunlight simulators at the Hycon plant. The project developed liquid nitrogen cooling loops for the camera's focal plane to maintain clarity. Records indicate that JMSUN pilots were trained in celestial fixed navigation using a sextant in case of electronic failure. Internal files verify that aged film emulsions were used to simulate the lighting conditions of different sensors. A quote from a declassified technical report on Archangel flight stability: "We are operating in a region where the laws of aerodynamics are written by the laws of thermodynamics." Quote from a declassified CIA briefing paper on aerial reconnaissance: "The photograph remains the ultimate arbitrator of truth in a world of strategic deception." Quote from a declassified memo from the Office of Scientific Intelligence: "The technical requirements for JMSUN push the limits of every material known to man at the time." Quote from a declassified CIA internal history report: "Intelligence gathered by these overflights has saved the nation billions of dollars by allowing us to avoid a blind arms race." A quote from Ben Rich, former head of Lockheed Skunk Works: "The A-12 was not an airplane. It was a leap of faith into the vacuum." That's a good one. And another quote, this one is attributed to a Lockheed test pilot whose name is redacted: "At that altitude, the world looks peaceful, but the camera knows better. It sees the machinery of the end of the world." And lastly, a quote from Richard Bissell: "We are looking for a needle in a haystack, and we have built a magnifying glass the size of a mountain." End quote. If you look at the final operational review of JMSUN, you will find a section titled Annex K, the Midnight Liaison. It is completely blacked out. Over 80 pages are redacted under Exemption B1 for national security and Exemption B3, which refers to statutes that protect intelligence sources and methods. What are they hiding behind those bars? I believe these redactions cover planned inertial sovereignty violations, where the agency developed protocols for denial of responsibility even if a pilot was captured. I also believe the redactions hide nuclear flash detection protocols, sensors that could detect the atmospheric ionization of secret underground tests. Finally, I think the blacked out pages contain the corporate partnership list, the names of global contractors who provided the sponsorship and work sites for these operatives. The redacted volumes suggest a level of public-private collusion that would fundamentally rewrite the history of American aviation if ever fully exposed. When a plane flies so high it can't be seen, the imagination fills the gaps. For instance, there are some theories, like the time dilation theory. Theorists speculate the A-12 exploited relativistic time slips caused by extreme speed. They argue the agency captured probabilistic next steps of Soviet growth, essentially using the Archangel as a predictive time machine. Atmospheric seeding. Some believe JMSUN dropped conductive dust to create a temporary artificial ionosphere. This would bounce radar signals around the Earth's curve, turning the entire sky into a massive antenna for eavesdropping on the Kremlin. Then there's the shadow government exodus theory. This posits the program mapped high-altitude sanctuaries in the Andes. Speculation suggests the agency found locations hidden in permanent shadows to build secret bunkers for a post-apocalyptic ruling class. And then there's the deep space interception theory. Radical theories claim the aircraft's quartz windows were tuned to intercept non-terrestrial signals. This suggests that while the cameras looked down, specialized antennas looked up to gather intelligence from cosmic or alien sources. Was JMSUN a success? Tactically, it was a revolution. For the first time, the fog of war was lifted. The project proved that strategic overflights could provide actionable intelligence that human spies could never reach. It successfully mapped the Soviet air defense network and gave the U.S. the confidence to negotiate arms limitation treaties because they could finally verify the other side's claims. Strategically, it was the blueprint for global transparency. It established the doctrine that national sovereignty stops where the atmosphere ends. This project forced the transition of the entire intelligence community from inference-based guessing to evidence-based certainty. It created a new world order where the ability to see everything became the ultimate deterrent, shifting the balance of power from the largest armies to the most precise lenses. As far as operational and technological breakthroughs go, JMSUN led to quite a few. For instance, titanium milling and welding. The project forced the invention of new ways to work with heat-resistant alloys. Current use, foundation of modern aerospace engineering, used in SpaceX rockets and turbine engines. Military and intelligence community application. Today, the intelligence community uses these advanced metal techniques to construct deep-sea surveillance holes and hypersonic glide vehicles that can survive the extreme friction of re-entry while maintaining structural integrity for reconnaissance sensors. These materials are also used in the armor of next-generation tanks and the heat shielding for the prompt global strike missile systems, ensuring that offensive assets can withstand the extreme thermal loads of high atmosphere transit. Image stabilization at Mach speeds, developing gyro-stabilized mounts that prevented vibration blur. This is the direct ancestor of the optical image stabilization in your smartphone camera. Modern unmanned aerial vehicles or drones utilize advanced versions of these algorithms to maintain a locked target track for miles away, allowing special forces to maintain a constant gaze on targets in high wind or high vibration combat zones without losing visual clarity. This tech also guides the seeker heads on precision guided munitions, allowing a cruise missile to identify a specific window in a building while traveling at supersonic speeds, effectively turning every bomb into a camera with a conscience. Radar cross-section reduction, the birth of stealth. The project used chine shaping to deflect radar waves. Current use, it's the DNA of the F-22 and B-21. Military and intelligence community application. The Department of Defense now applies signature management to everything from naval destroyers to silent special operations helicopters. This low observable technology is the primary requirement for any asset operating within anti-access area denial or A2AD bubbles. Furthermore, the intelligence community uses this to build electronic warfare drones that can simulate the radar signature of a large fleet, deceiving enemy defenses while the real stealthy assets move through the shadows of the spectrum. High-resolution emulsion chemistry, creating film that could resolve micro details without graininess. This paved the way for modern digital sensor architecture and numerous sensors. As far as military and IC application, the National Reconnaissance Office utilizes subpixel processing derived from this chemistry to perform spectral analysis of foreign launch sites. This allows them to identify the chemical composition of fuels from a photograph, providing a technical signature of a missile's range and payload from space. Additionally, this allows for forensic imagery where the military can reconstruct a 3D model of a compound from a single 2D photograph by analyzing the micro shadows and texture density of the surface. The legacy of JMSUN is not found in the museums where the Archangels now rest, but in the very fabric of our modern perception. Every time you open a map on your phone or you see a satellite image of a storm brewing in the Atlantic, you are utilizing the vertical sovereignty claimed by this project. We have become a civilization that expects total transparency from above. We have traded the mystery of the horizon for the clarity of the overhead shot. This program didn't just map the Soviet Union. It mapped the psychological end of the hidden world, ensuring that no corner of the earth remains beyond the reach of the lens. In the past, the great empires were defined by the territory they could hold with boots on the ground. After JMSUN, power shifted to the territory you could hold with a shutter click. This transition fundamentally altered the nature of global diplomacy, turning secret tests into public facts and making the element of surprise almost obsolete for those without stealth technology. The Cold War ended not because of a grand battle, but because one side could no longer hide its weaknesses, and that visual vulnerability began the moment the first A-12 breached the stratosphere. Today, we live in a panopticon of our own making where the line between national security and personal privacy has been permanently blurred. The same optical breakthroughs that identified missile silos now track our delivery trucks and monitor our borders. We are the children of the solar sentinel, living in a reality where the intelligence of light illuminates everything but the motives of those who hold the camera. We have conquered the void, but in doing so, we have ensured that the void is always looking back at us. Keep your movements private by understanding the solar angle of your shadow. Keep your eyes wide open for the sky spy that hides in the glare, and keep your ears sharp for the sonic boom of a ghost you'll never see. And remember, sometimes the most dangerous eye is the one that looks down from the edge of the void. Join us next time as we examine AE Gear, a project dedicated to the technical development of specialized vehicles for cross-border infiltration. Imagine a car that isn't a car, a chameleon on wheels designed to vanish into the background noise of a foreign city while carrying hidden cargo. Join us next time for the Ghost Transit. In the meantime, I'll see you in the archives.